But just to give a small recap, kind of to follow up what Lan was saying in the beginning, we have a lot of different code bases. There's a kind of a supporting software. There's a little bit of applications, and we need more applications to actually execute NDN code base in different variants. And we have a large number of different libraries, like starting from the basics, like NDN CXX, NDN CCL, like the set of basic NDN libraries for different languages, which not only include basic components like interest data exchange, but also include the higher level elements, like you can. It's not yet like a BSD socket API, like or like a consumer producer APIs, but something higher than the interest data exchanges, but still a little bit lower. Chronosync, psync, this is like synchronization libraries. NDN RTC Peter has been talking a lot, but we have been working for a few new libraries to effectively improve security, or how to use security in a different way, in more simple way. Like security is still hard. You still need to require a lot of, not a lot of, some of the bootstrapping has to be done offline, but it needs to be done, kind of the rest process has to be as simple as possible or as painless as possible. And again, if somebody forgot that we have an NDN website, this is actually the starting point for everything that we have been talking today. And all the slides, all the videos that we're trying to capture will be published on NDN website. So go there. I think slides for this tutorial already uploaded, so you can already take a look. Okay, so kind of focus for this specific part of the tutorial is on 3 items, and kind of 2 related to security and 1 NDN. So first one, I'll kind of highlight a little bit of data-centric confidentiality, and specifically the approach that we've been working is name-based access control. So effectively, what kind of data-centric confidentiality is, kind of instead of trying to secure and like encrypt the channel between kind of 2 endpoints and kind of then put the data in this channel and kind of rely on the security of the channel or kind of security of the perimeter, we put the kind of encrypting data itself and then exchange this specific data over any kind of channels that we would like to. I mean, these channels still can be secure if needed, but that's kind of outside the scope of data centricity. And the key challenge in this environment, instead of is key management. Because now you have the data has been signed by potentially some symmetric key. You need to kind of reliably give this key to only authorized parties, and this potentially be encrypted with some asymmetric key, and potentially this can create a kind of mess. But what we're trying to do is kind of leverage naming. Remember what we talked before, we name everything. So we name all the keys and name also conventions how to retrieve keys that has been encrypted by another keys. And I'll try to highlight with a few names. There will be kind of a bit details shown on the slides. Don't be kind of afraid, or not afraid, puzzled. There will be a little bit more explanation in the second part of the tutorial. Right now, I'm just trying to highlight the use of names, or kind of the names can be used in a different way. And to kind of highlight the idea of how it can, kind of this data-centric authenticity can be applied in applications, or like a real application that Jeff has been talking earlier. So for the AR application, and specifically what we did in the project, there's a different types of data that needs to be secured in slightly different ways. So for example, and kind of there's kind of several questions of how exactly it needs to be accomplished. So what we have in that environment is mobile terminals that is producing data. So it can secure data in one way. But then there is a kind of so-called edge node, edge nodes, who needs to get access to the data in order to process them. So kind of the mobile node kind of capturing the video, and it's a desire to get some context associated with video is being captured. So kind of it needs to give access to the edge nodes kind of to process the data. but then the H nodes needs to give the access to the node back to the nodes. So that's kind of the simplest solution. Or they may give access to some of the context to a larger group of people, so others can also benefit from if the video has been captured from different angles, so the others can also benefit from the pre-calculated context or pre-detected context if multiple people are trying to get to the same thing. So there's a what the objective for showing this is just to highlight the policies for the data encryption or data confidentiality can be quite complex, and there are different levels, but they still can be controlled. So what we have as part of the implementation of name-based access control, so we extracted 3 entities in the whole system. Some of these entities can be combined as one node, or be delegated completely different nodes, or they can play different roles at different times. So the access manager is something that defines the policy of data being encrypted, and it's serving a point of indirection between who actually produces the data and who wants to get the access to the data, or who is being authorized to get the data. And so for this version, we're trying to use RSA public key crypto for indirection purposes. So if I go, let me go from some direction, I have a little bit more details. So if I go from the encrypting content, so when you produce the content, you encrypt the same content with some symmetric key that's being generated. And then that symmetric key needs to be encrypted, and encrypted in this specific case using the policy that's associated with the policy grantor, and the granularity of the data is being encrypted. So that this grantor can define different policies for different data. So the policy, policy is a good word, but what it in reality means is simply stating that the data encrypted under this policy can be accessed by this set of people. And this this concept of being accessed by, or being able to be accessed by this set of people in this environment, in this solution, is defined by this set of encrypted versions of private key. And what you can see on the slide, what is highlighted in the name. So we're trying to play name tricks as part of this process. So we have the part that identifies the private key that associated with the policy. So if you somehow get the actual private key and you know this name, then you can effectively decrypt the data. But you don't want to send this private key in plain text, because otherwise it defeats the purpose. So we have the second part, whoever is being granted the access simply can construct and add this part to the name. So if I again continue the reverse the process a little bit, so the decryptor will simply receive the encrypted data, and that encrypted data simply identifies that there is some name of the symmetric key that has been used to encrypt the data. So the second step, in the decryption, is to retrieve that symmetric key using the name that was identified in the data packet. So that symmetric key has a some name that the data producer has defined. The name, after retrieving the symmetric key, after this content key, the name or the content of the symmetric key identifies what is the policy this symmetric key is attached to, effectively saying that this symmetric key. Oops. I think I'm missing some name somewhere. No, sorry. So this symmetric key is subject to this policy. I'm missing granularity part in this name. So now we have a policy name. And then as soon as we get the policy name, we can construct the actual name to retrieve the encrypted version of this private key using my identity as part of the whole name. So if I'm being granted access, I can simply, this data packet will exist somewhere in the system, and I will be able to access the data. If I'm not granted access, then I will get some kind of negative acknowledgement or some other indication that I cannot access the data, or I simply cannot decrypt this thing. So the process is, as you can see, the construct of name none that trivial, and I would not want application developers to actually reproduce this kind of picture like in their minds, and then kind of write the code against this picture. So what we have is a quite simple API, like in the library that I hope will be able to show, at least in the basic version, show example. So the API is quite simple. So you can create this so-called access manager and kind of generate keys, as Peter showed, and we'll show additional examples later, and grant access using kind of effectively certificate of the guy whom you want to grant the access, and that's it. Like all the mechanics of actually granting the access, creating this encrypted version of the private keys is kind of hidden inside. If you want, so this would be kind of online process. So if access manager is always online, then it will serve those private keys. But you can also kind of enumerate all created data packets that was part of this access manager and dump them in some repository. So now this access manager doesn't have to be online anywhere. Like it can just disappear from the picture, and still everybody who granted the access will be able to have the access. And producers who encrypt the content will be able to also encrypt the content in kind of, because the policy is still kind of available out there. And kind of when I showed here is the encryption process, also quite simple. Simply specify what you want to, what kind of policy name, which effectively defines that the name defined by the access manager. This data is subject to, what kind of prefix for the symmetric key that's been generated or regenerated, and kind of the rest is quite simple. And the API for the decryption part is even simpler, because you only need to identify, kind of specify what is your credentials, and the rest of the process is asymmetric, because there's sometimes, not always, there's a multiple round trips, but there's everything else kind of done in absolutely automatic fashion. Again, there will be a little bit more on this. We also have attribute-based encryption version, and G will be talking a little bit more about that. We still need to play more with applications. We have a few pilots that we're trying out this system, but again, it's not enough. It's just a very basic implementation and basic logic, and we need to improve it further. Another piece that kind of library slash system slash protocol is the NDN cert. We have been talking a lot about the certificates, that in the end every data packet has to be encrypted, and we'll be talking later that everything has to be bootstrapped, and there's a trust schema to define those relationships between data names and key names. But you really need to kind of have those keys in a system, and you don't really, in the next tutorial we'll show how to do it manually, but you don't really want to do it manually, especially if you consider like a big system or kind of internet-like scale system. So what we kind of did, we designed the NDN cert protocol, which automates a lot of things as part of the NDN certification process. You still need kind of, because of security, you still need some kind of offline in quotes, or some kind of challenges that you can prove that you possess something, like if you're requesting some specific namespace, or if it's about claiming some namespace, like in a Facebook, you create an account, you just need to claim some namespace and be stable, have a private key that's associated with some namespace. So this is kind of what the protocol is kind of about, and highlights. The whole protocol was inspired by the ACME, the automated certificate management engine. For PKI system. So, but that one is specifically designed for DNS-based, effective DNS-based challenge validation. In here, we kind of try to generalize. We're not yet too far succeeded in like really generalizing. What we have is a few kind of the protocol itself and a few challenges that we think we could think of in this environment. So simply you request a certificate with a special signed interest. You request a set of so-called challenges that you may use to actually request the name to get the certificate for the namespace that you're claiming to. And this challenges depends on the configuration of the system. And then there's a process of selecting challenges, satisfying challenges, and actually downloading the system. And the reason I'm kind of showing this process is not just show that this system exists and there are CAs that can deploy this server and kind of run this protocol so the clients can get certificates. In NDN, everybody can be a CA, and kind of we're embracing the concept of a local trust anchor. So as soon as you, I mean, if you work in like in local home environment, you just create your trust anchor, you self-sign something, and this becomes kind of your certificate, and all your devices run this NDN server protocol to get the sub-certificates for specific sub-namespaces from this trust anchor. One can, again, whatever individual devices can also run either internal NDN server protocol, so the application instances get the proper certificates from the device that was actually trusted, kind of rooted in an original trust anchor that is mine. Or kind of this still can be used in kind of in the internet-like environment where there's like a testbed root, so we have it for NDN testbed. And the last piece that I want to show is the APIs. So you may be kind of a little bit sad seeing like a little bit complex API that we have. And this part is still kind of undergoing work. So we didn't really design it as a library to be embedded in applications, but rather primary target was a set of tools that can be added in this kind of, so we have a command line tools and some graphical interfaces. So that one kind of working, and we still need to have a very, very simple, well, a set of simple APIs for the applications to actually simply request certificate, and that certificate being generated, published properly in different places. So this is still ongoing work, but it's already a huge simplification of the process of the burden on the applications to manage all the certificates. So you don't need to kind of create key manually. You don't need to kind of send this request in some offline manner or whatever email, like then download in command line to do like a signing process and then getting a certificate back. All this protocol mostly automated. Okay, and I'll give Jeff time to talk about very exciting thing called the common name library, which kind of deals with the names.